Hello, I'm Professor Amanda Malefyt, and I'm here to provide an example of where I incorporated a YouTube video assignment into a course. In the fall semester, I teach a chemical engineering fluid dynamics course, and I have found that having students generate their own problems strengthens their ability to apply chemical engineering theory into real-world applications. When students are working in industry, their problem-solving tasks aren't going to be wrapped up into neat little packages of 1 to 2 paragraph problem statements. Part of solving the problems at hand involves knowing what variables need to be measured or researched in order to estimate a feasible solution. Having students generate their own problem statements reinforces this skill. Additionally, creating clear, descriptive problem statements allows students to refine their communication and technical writing skills. As previous videos in this series have shown, adding a video to this type of assignment also has added benefits to student engagement and learning. These include improved retention and providing real-world context. The example I'm providing today I used as an individual assignment with a peer review component, and I assigned it as a review activity prior to the final exam of the course. And so you can see the problem statement. It was related to mechanical energy balances utilizing an unknown flow rate or an unknown diameter. So the students had to find an online video related to fluid flow, design their own problem that required solving for volumetric flow rate or pipe diameter, some specifications on what things they had to include for the complexity of their problem, and how they needed to solve it. And so this assignment was actually kind of divided into 2 separate homework assignments. And so in week 1, right, the students found the video and wrote their own problem. And then I actually had them post this to a forum-based discussion on our learning management system so that all the students could see all the other students' problems. And so then I kind of called it week 1.5. So halfway between the first due date and the second due date, right, their job was to look at all those posted problems and solve another student's problem. I think it's really good for the students to have to solve another problem because this kind of adds an extra check before I go to grade the assignment. There's already someone else that has kind of vetted the problem and at least made sure that all the required information is there and that some type of solution can be achieved. And so once they've done this, then the student who wrote the problem then posts their solution. Posts their solution on that post for the forum. And then for that final assignment due on week 2, revised problem is submitted. So what I usually tell students, if their solution and the student that solved their problem solutions don't align, then they need to figure out what needs to be fixed. This can be making sure that the problem statement is clear, includes all the necessary information to solve the problem, and then they can make adjustments as needed. So I tell the students that little to no credit will be given to problems with incorrect solutions or cases where these 2 solutions that are posted don't align. So the student that solved the problem and the student that wrote the problem have to work together to figure out if it was an error in solving the problem or an error in what was given in the problem statement and come to a consensus on the best format of the problem. So once you have these problems, there are several different ways that you can use them in future courses. So I kind of wanted to show you an example of one of the problems that I had a previous student come up with. So they designed their problem around the Eiffel Aqueduct, built by the Roman Empire to supply water to the present-day city of Cologne. And they give the information, and they're asking the students to find what flow rate of water is able to be provided to the city using gravity as the main driving force. and then a link to a video that talks a little bit more about the history of the aqueduct and shows it in person. And so you can use these problems either as in-class activities. If you do kind of a flipped classroom type version of your class, they can work on previous versions of these problems in the class. I can assign them as homework problems or give them out as extra review problems that the students can look at prior to a test or a final exam. Another thing that I like to do with these problems that has worked out well in the past is that as I'm assigning them, I cite the student that authored the problem and say, this problem was written by this student, who is currently a senior. And upperclassmen students really get a kick out of hearing that their problem was assigned as a homework assignment, and they really love it when they can hear underclassmen complain about how difficult their problem was to solve. So it adds a little extra rapport between the different grade levels of students. And so that's just my example of how I incorporated a YouTube video problem into my fluid dynamics class for chemical engineering.